Hey everyone, welcome back to this example. In this example, we'd like to determine whether the lines are parallel, skew, or intersecting. And if they are intersecting, we want to find the point of their intersection and the angle of their intersection, or at least the cosine of their angle of intersection. So first we need to talk about what do these words mean, right? Parallel, skew, or intersecting. And it turns out that in two-dimensional space, there are only two possibilities if you have two lines. Either those lines intersect or they don't, right? If they do intersect, then they could be, then they make an angle, right? They have one point of intersection and they make an angle. If they don't intersect, then we call them parallel. But in three-dimensional space, it's possible that neither thing could happen, right? So parallel should mean that the two lines have the exact same direction. So for example, let's say I'm going to try to draw two parallel lines. So these are non-intersecting lines. And the idea here is that they have the same direction. So L1, L2. And if L1 is parallel to L2, then this means that their direction vectors, so V1, is equal to some scalar multiple, say alpha, of V2, where alpha is not 0, of course. And well, it could be. If they're both, for alpha to be 0, V1 and V2 would both have to be the 0 vectors to begin with. But then they're not lines, so it can't be. Alpha can't be 0. I talked myself into that and then out of it. All right, so there you go. That's what parallel looks like. That's exactly what we're used to, right? Perpendicular is then, I'll draw perpendicular up here with this line L2. And by the way, as I draw this, you're going to see that this third line is the only one that we need. So L2 is perpendicular to L3 because they intersect. So they intersect here at point P. They intersect at an angle of pi over 2. So this is at pi over 2. I mean an angle of pi over 2, right? By the way, if that angle is anything else, they're still intersecting. So, if you do something like this, say we have L4, L4, L3, L2 are all intersecting, and they're all intersecting at that same point there, right? But here's the idea. Now L4 I've drawn so that you can really see that L4 is not supposed to be intersecting with L1. So it's also not in the same direction as L1 because it shares a point with L2, but it's not in the same direction as L2. So L1 and L4 in this picture that I've drawn here are called skew. So L1 and L4 are skew. And this just means they are not intersecting and they're not parallel. All right, so let's take a look at our lines that we're given in this problem. So the first thing we want to do is check to see if they are parallel. All right, that's the easiest thing to check first because if they're going to be parallel, then we can just look at their direction vectors and we can know. Or at least if they have the same direction, right? The first step to being parallel is they have the same direction. So the direction vectors come from, you'll remember, I'm sure, these coefficients on the parameter term. So over here, the parameter is t, and on this line L2, it's a different parameter, and that's just so we don't get mixed up about what t means. So over here, the parameter is the s. All right? And at this point, we want to just write down the direction vectors. So for this one, the direction vector V1 is -12, 9, -3. Over here, the direction vector V2 is going to be 8, -6, and then 2. And we want to know, are these two vectors multiples of each other? And so the one thing we can do is we can just look at, what we have to do basically, is look at the first components and figure out what the scaling factor must be. So if we want to get from -12 to 8, we have to divide by 3 and then multiply by -2, right? So our scaling factor, I'll call it k, has to equal -2/3. And then we just check and see if our components all obey this or not. And if any one of them does not, then they're not in the same direction, right? So let's just to make sure that I did this right, let's do -2/3 times 12. Well, that's 4, that's -8. It was times -12. Do it correctly, right? That's +8, so check mark. That one works, right? Go to the next one. So -2/3 times 9. Well, this is going to be 3 times -2. That's -6. Check mark. That one works, right? Let's go to the next one. So -3 times -2/3. This is going to be +2. Check mark. So look at that. That means then that these lines have the same direction. They have the same direction, right? So the next question is, are they intersecting, right? Because if they're intersecting, these could just be two copies of the exact same line. That's possible, that these are just two copies of the exact same line. And in that case, they would be not parallel, I guess they would be intersecting at all points, right? But they would be the same line, in other words. That's what they would be. So what do we have to do? Well, we want to find out, is there a point, right? Is there a point on both lines that shares the same x, y, and z values, right? So if it's going to share all the coordinates, it's got to at least share its x values. And by the way, in general, even if your lines are not parallel, this is how you check if they're intersecting or not. So I want to see if these are intersecting. So I'm going to say, all right, if they're intersecting, the x has to equal the x, right? So on the left-hand side, 5 minus 2t, 12t, that's the x value for line 1, has to equal 3 plus 8s. And we can use this to find a factor, right? We can find a relationship between t and s. So let's get everything solved for, I don't know which one, doesn't really matter. Let's solve everything for s in this one. So we'll subtract 3, divide by 8. So over here we're going to have 2 minus 12t equals 8s. And then this tells us, right, that s is going to be 1/4 minus, and we already did this calculation, this is 2/3, right? Nope, this is going to be 3/2. Sorry. Minus 3/2 t. And so this has got to be the relationship between s and t. And so now what do? Now we go back to the other two equations, and we plug in this value of s, and make sure that we get the same value of t back, right? So over here, we're going to plug in y equals. So on one hand, it's 3 plus 9t. And on the other hand, it's going to be negative 6 times s. All right, but negative 6s is negative 6s is negative 6 times 1/4 minus 3/2 t. All right, and here's what we do now. We have 3 plus 9t equals, on this side, this is going to be negative 3/2 plus 9t, and these two 9's are going to cancel, right? 9t's are going to cancel, 9t, and look what we're left with. 3 is equal to negative 3/2, and that is what we call shenanigans. This is my mathematical symbol for shenanigans. This is a contradiction. Those two are not the same, right? 3 does not equal negative 3/2. So what do we conclude, right? We didn't even have to use the z component. What we found is that if the x's are equal to each other, there's no way, right, that the y's can be equal to each other. It's impossible. So once you reach a contradiction here, you say the lines do not intersect. All right. If you're going to show that they do intersect, then you have to find a parameter, a value of t, which works for both the y's and the z's. You have to get the same value of t for both the y's and the z's. Okay. And so at this point, what do we conclude? Well, our lines do not intersect and they have the same direction. Therefore, L1 is parallel to L2 in this example. These lines are parallel.